Hey everybody, we are starting our new unit about something called differential equations. And usually differential equations are set in context, aka story problems. We, however, are going to start out with keeping the context out so we can learn just the mechanics. And then once we have the mechanics down, we'll move on to the context. So you'll see phrases like solve the differential equation. Or you'll see also solve the differential equation subject to the initial condition. Now, when you see either of those phrases, you have to automatically know to do 3 to 4 steps. And there's, of course, multiple steps inside those steps. Okay, so this right here is a differential equation. And basically what this means is that, like, if you knew some point, let's say 2 comma -5, that means the slope dy dx would be x divided by y. So at the point 2, -5, your slope would be -2/5. Or if you had the point 1, 1, your slope would be 1. That's an easy one. So basically, we're starting with this. Hey, we have the slope stuff here, and we have an initial condition. What's the equation that is actually fitting this situation? So to get there, we're going to follow these steps. So our first step is what's called separating the variables. And separate the variables is another phrase you have to automatically understand. And what it really means is to get y hanging out with dy and get x to hang out with dx. And you might have other stuff tagging along for the ride. We'll see that in future examples. So I'm going to separate my variables. So to get the y to be with dy, I can multiply both sides of the equation by y. And then while I'm at it, I can multiply both sides by dx, because that will move the dx to hang out with the x. So we have y times dy equals x times dx. So there's step 1. In this case, it wasn't too bad. Later, the algebra can get kind of hairy. Okay, so that's step 1, separate the variables. Step 2 is to integrate both sides. So if I integrate both sides, the left side, I'm going to have a 1/2 y squared. And of course, we have a plus c. And then on the right side, we have a 1/2 x squared plus, plus c. Actually, this c and this initial c, those are different c's. Like this might be a +1, this could be, say, a +2. But really, if we just plug in, if we just have a plus c on one side of the equation, it's going to serve the purpose. Because like adding 1 on the left and say 3 on the right, I'm changing my numbers there, that's really the same as just adding a 2 on the right. So really, we're not even going to put it on the y side. So future examples, we won't even have that show up at all. Okay, so that's the integrating both sides. And remembering our constant of integration, that plus c. Okay, step 3, solve for y. So obviously I can multiply both sides by 2. So I have y squared equals x squared plus 2c. Now some books, when they're multiplying both sides by 2, they actually still, since a c is a constant, and if I double the constant, it's still a constant, some books will actually just say, like, I'm still going to call this a plus c on the right. That makes me feel algebraically uncomfortable, so I don't play that game. I just leave it as it is. Okay, continuing in my solving for y, be really careful with this because we have this y squared. And if I take the square root, it could be positive or negative. So really, it's plus or minus the square root of x squared plus 2c. That plus or minus thing is going to show up actually a fair amount. We'll see that in our next example as well. Okay, sometimes if you're not given an initial condition, and this guy right here is our initial condition, if we didn't have the initial condition, we would be done right now. Be like, woohoo, we finished. But since we have an initial condition, this is basically giving us more information, because this could be just any old function, whether or not it's positive or negative, I don't know. But the one thing I do know is that it goes through 2, -5. So I can plug that guy in. So I have -5 equals plus or minus square root of 2 squared plus 2c. Okay, Right now, we have just answered the question of the plus or minus. In order for me to have a negative after taking a square root, to get the -5, it has to be that negative. So if this had been the point 2, 5, it would have been the positive square root. So you have to be really careful with your algebra and apply that logic. Okay, so if the square root of this thing is -5, that means that that thing on the inside, that 4 plus 2c, oops, I just wrote 4c. Yay for erasable pens. 4 plus 2c, that has to be 25, right? So that means the 2c is 21. I'm not going to bother dividing by 2 because I'm just going to go back and plug that into this original y equals. So we have our final answer here is y equals the negative, to make it pass through the negative, and then x squared plus my 2c, which was 21, square rooted. So this is in 4 not so quick steps solving the differential equation subject to the initial condition. We're going to see what this stuff looks like graphically later as well, but again, right now we're just dealing with the mechanics. Okay, it's time for our second example. So once again, we have a differential equation and it has an initial condition, and we are going to solve the differential equation subject to the initial condition. I'm going to keep saying those phrases so that you get them in your head. And I suggest writing these steps down. You could even have them on a, note card so they're conveniently available for your use. Okay, so I know this looks almost exactly like the previous example of x over y, but there's some interesting things that happen with the algebra, so stay tuned. Okay, so we're going to first separate the variables. So I'm going to just start out by multiplying both sides by dx. So I have x times y times dx. And then to get the y to be hanging out with the dy, I can divide by the y. So I have dy over y equals x dx. Okay, so there's our separate the variables. Get the y hanging out with the dy, get the x hanging out with the dx. Okay, next we're going to integrate both sides. So I know that dy over y, we've seen that form a lot. It's the natural log of the absolute value of y. And then the x, integrating that, we get the 1/2 x squared, and then our plus c. Remember, we're going to just put the plus c only on the side with the x. It could go on the right side, but we'd end up moving it over, so that's just a wasted step. Okay, so that's the integrating both sides, our step 2. So step 3, and this is where we really have to pay attention. So we need to solve this guy for y. Remember that to undo a natural log, the opposite of a natural log is an e to the. So if I do e to the on both sides, so I have e to that, all that stuff. So on the left, I have the absolute value of y. On the right, I have this e to the x, 1/2 x squared plus c. Now, you've seen it before where you have if you have a squared times a cubed, you would do a to the 5th or a to the 2 plus 3. I promise there's a reason I'm bringing this up. So if we look at this in reverse, a to the 2 plus 3 is the same as a squared times a cubed. Same logic here, and I have a reason to do this. So on the right, I have e to the 1/2 x squared times e to the c. And again, I have a reason to do this, I promise. Okay, remember, c is a number. So e to the c is a number. Okay, keep that in mind. Okay, continuing here, I'm going to slide this up. So I have absolute value of y equals this thing. Now, if I had absolute value of a equaled 7, I would know that a was either positive or -7. So the way we get rid of that absolute value is a plus or minus on the other side. So y equals plus or minus, and I'm going to rearrange, and I have a good reason, e to the c times e to the 1/2 x squared. Okay, remember how c is a number? Well, e to the c is still a number. And if that number is positive or negative, it is still a number. So this ugly thing right here, we can actually make it a simpler thing. And what we do is we actually make a little statement, let c sub 1, which we usually just say c1, equal plus or minus e to the c. So now we have this simpler looking thing of y equals c1 times e to the 1/2 x squared. because that's much prettier. Okay, so that's the solve for y step in our not so easy 4 steps. So finally, our last step is going to be to use the initial condition to find our constant of integration. Our initial condition is 0, 3. So y is 3 when e is 0. Oh, that's convenient. E to the 0, of course, is 1, so c1 is 3. And that was a lot easier to solve for just c1 than it would have been to solve for the c when it was way back buried inside of exponents. Okay, finally, our last step is just to write our equation. So we have y equals c1, which is 3, times e to the 1/2 x squared. And there's our second example. So the thing to really watch on this is the algebra in the solving for y and paying attention to all those details. Okay, example 3 time. Woohoo! The fun never stops, or it just seems that way. Okay, so our third example, we have dy dx equals sine x over e to the y. And of course, our first step, separate the variables, get the dy and y hanging out together. So I'm going to multiply both sides by the e to the y. So I have e to the y, and while I'm at it, I'm also going to multiply both sides by the dx. So I have e to the y dy equals sine x dx. So there is my separate step. So separate our variables. By the way, on the AP exam, so under normal circumstances, and I don't know what this year's going to look like, but under normal circumstances, this kind of question shows up in the free response questions. And free response questions are 9 points. There are 6 of them, making half the test. So of the 9 points, this question would end up probably being 6 of those points. So this is like a heavy points kind of question type, and it shows up really frequently on the AP test. So it's a good idea to learn this stuff if you are taking the AP exam, because it's one of the most controllable things. It's pretty predictable. Okay, so we've separated our variables. If you don't do that, you will get 0 out of 6. Okay, second step, integrating both sides. So that we know that e to the thing that has a derivative of e to the y is just e to the y. Straightforward. How convenient. And then we know cosine has a derivative of negative sine, so negative cosine. X has the derivative of sine x, and our plus c. So here's our integrating both sides, and our plus c is in there. And by the way, if you didn't have the plus c on the AP test, well, things stop making sense if you don't put the plus c in, because the initial condition stuff doesn't make any sense. Otherwise, it won't fit, or probably won't fit. And they'll give you on the AP test like maximum of like 2 out of 6. It hurts. So we have our integrating both sides taken care of. So next step is the solving for y. And remember that since natural log and e to the are inverses of each other, they undo each other. If I do the natural log of both sides, it will undo that. If we have natural log of e to the y, it's just the y. And then on the right, I have natural log of negative cosine x plus c. And I know you're probably thinking, but wait a minute. You can't take the natural log of a negative. Shouldn't that have absolute values on it or something? Probably not, because the plus c is actually going to take this negative cosine x and move it up into a place that will never be taking the natural log of a negative. So we actually don't have to worry about that. The only time we have to worry about it is on our previous example, when you have that like dx over x integral and you integrate it. Okay, so we have our solve for y taken care of. And again, if you didn't have an initial condition, you would be done here and you could go skipping off into the sunset. Instead, we will plug in those points. So I have natural log of 5 equals the natural log of negative cosine pi over 2 plus c. Just a reminder, cosine of pi over 2. Here's your cosine x graph. So, and that's 2 pi, and that's pi. So pi over 2 is 0. And hopefully you'll know your, cosine graph and your sine graph. Or you can find them on the unit circle. However it is that works for you, do it. So anyway, cosine of pi over 2 is 0. Whether or not it's negative or positive doesn't really matter. So I have natural log 5 equals natural log of 0 plus c. So c is definitely 5. So I have y equals natural log of negative cosine x plus 5. And there we go. And since cosine of x is always between 1 and negative 1, whether or not you're positive or negative, when you add 5 to it, you're always going to be greater than 0. So no worries about taking natural logs of negatives. I'm sure you were worried. You weren't worried. Anyway, this is how our differential equations go. These are the steps to keep in mind. And obviously, any of these steps can get really hairy on the algebra, but we'll survive it. We'll get good at it. And we're spending a couple of days on it.